Hi, for this video, we're going to be finding the distance between 2 points. I'm doing 2 different examples because there are 2 different formulas that I tend to show my students. One that requires you to show work and one that allows you to do the work in your head. So it's kind of a preference thing of which one you like better. For the first one, we're going to use the traditional distance formula. And the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. And the x2 just represents the second x coordinate. Remember that our coordinates are always x comma y. So if it helps, you can always say that this is x1, y1. This is x2, y2. If that helps you to see where you're pulling your information from. Essentially what the distance formula is the Pythagorean Theorem, that a squared plus b squared equals c squared, where c is always the hypotenuse. So the distance between the 2 points is really just the hypotenuse between those 2 points. So this formula is something that you tend to have practice with, but you don't realize it a lot of times. So what we're going to do is we're just going to take and plug in our values. For x2, I'm going to plug in -2. Be very careful about signs. For x1, we're going to plug in 3. And for the second one, y2 is 12 minus 7. And then you would do, then you would square that answer. So with this, we would just simplify. -2 minus 3 is -5. 12 minus 7 is +5. And don't forget that right here, sometimes I see a lot of mistakes with negatives, especially putting it into their calculator wrong. Remember that since we're squaring the negative, it does become positive. So this is really 25 plus 25, which is the square root of 50. And depending upon the course that you're in and the style that they want it as, if they ask for an exact solution means that you want to leave it in terms of radicals. So you would want to just simplify what you can underneath here. There's a couple different ways to simplify your answer. One way is to use a factor tree and to break this down into its factors. This is really 5 times 10. And 10 is really 5 times 2, and we can see that the 5 repeats. And then any repeats, because I can take the square root of a squared term, would go on the outside. And then anything that does not repeat would stay underneath the radical. This is one way of doing it. The other way is you could go through and find what perfect squares divide into here. So like, can I do 50 divided by 4? Or can I do 50 divided by 9? 16, 25 is the first one that we see, and then the square root of 25. So I could write this as the square root of 25 times the square root of 2. And then the square root of 25 is 5. So it's kind of one of those things where you get the same answer. I know I have a lot of students that tend to like the factor tree better because then they can physically see what repeats, and then anything that repeats goes on the outside. They don't necessarily have their square roots memorized, and so it takes them a little bit longer to do it the other way. If they ask for an approximate solution, then you would simply plug the square root of 50 into your calculator, and you would see that it is 7.7107. So because 50 is not a perfect square, we could get an approximate answer if that's what they're looking for. So make sure that you read your directions. If it says exact, then leave it with a radical. If it says approximate, then you would just plug it into your calculator. For the second example that we're going to do, I'm going to use a shortcut formula. It's really the same thing, but it's just, it skips this step here so you don't have to show out the work. The other formula that I show my students is delta x squared plus delta y squared. This is delta, and it means change. So with this, you could simply ask yourself, how many places did I move? So for my x's, And you don't have to worry about the sign with this because of the fact that you're squaring it. The sign is going to change anyway. So I could just ask myself from -3 to 0, how many places did I move? So if I went on a number line from -3 to 0, I would move 3 places. So my change in x is 3. And then my change in y from 1 to -3, if I think on a number line from 1, and if I go down to 3, if I go down to -3, I would move 4 places, because from 1 to 0, I would move 1 place, and then from 0 to -3, I would move 3 more. And so then if I simplify this, this ends up with 9 plus 16. And so we end up with the distance is the square root of 25. And on this one, because of the fact that an exact answer, if I plug it into my calculator, I get 5 exactly. So that's what we would put as either the exact or approximate. Whether the directions said either one, you would just take the square root of 25. As always, thanks for watching. If you have any questions, please let me know.